Hello. Today I want you to take a look at one of my favorite integrals in the world. So let me write the integral out of this. In case it isn't clear, it's the integral of square root 1 minus x squared minus the integral of 1 minus x. So there are a couple of reasons why this is one of my favorite integrals, and honestly, one of the few questions I will ask people directly should they ask me for a math challenge. So first of all, let's start off by doing the integration method of this question. So first, let's deal with this side. The integral of 1 minus x from 0 to 1 dx will be equal to 1 minus x squared over 2 divided by negative 1 from 1 to 0. This will evaluate to 0 over 2 divided by negative 1 minus 1 over 2, which will give you plus half. So if you resubstitute it into here, it will be the integral of square root 1 minus x squared dx minus half from 0 to 1. But now we have to deal with the 1 minus x squared. And how do we deal with that? We deal with that by doing Trigono substitution. So let's just remember this answer and erase this. So the formula of Trigono substitution states that if you have a square root of a minus bx squared, you sub x equals to a over, this a squared b squared x squared. You sub x equals to a over b sine theta, or whatever variable you want. So as you can see in this case, a will be 1, b squared will be 1, b squared will be 1, x squared will be x squared lah. So in this case, we will substitute sine I like to use u, sine u equals to x. So by doing your integration by substitution, you differentiate this, and by implicit differentiation, this will give you dx cos u equals to 1. And you can evaluate dx as du cos u equals to dx. Substitute this into here, so you will get the integral of 1 minus sine squared u, then sub dx equals to cos u du. Then by your trigonometric identities, this reduces to cos u. So it's actually the integral of 0 to 1 cos squared u du. However, there's something wrong with this. Problem being is, in this scenario, we're integrating by dx. But in this scenario, we're integrating by du, so our bounds have to change. So when x is 1, what is the value of u? You apply your inverse function, so u will be sine inverse 1 when x is 1. Then when x is 0, u will be equal to sine inverse 0. So just resubstitute in. And we can integrate this together. So now by your double angle formula, you move over divide so now let's substitute this into here. the integral of sine inverse 1 to sine inverse 0, from sine inverse 0 to sine inverse 1 by half cos 2u plus half u du will evaluate to 1 over 4 sine 2u plus half u from these bounds. And if you do some substitution and all that, sine inverse 0 will be, this will be pi over 2, so it will be half sine pi plus half pi over 2 minus, this will be my bad, this will be 0, so it will be so your answer will be pi over 4. Therefore, the answer to the original thing that I requested will be pi over 4 minus half. But I want to introduce another method of doing this that does not involve integration at all. So the reason why this is one of my favorite questions is because it tests the applications of integration, and it's possible to solve it without doing integration. In fact, this was one of my textbook questions, and earlier this year I had not learned to do trigger substitution, and I solved this question without using trigger substitution. A note to take off before I continue is that I sort of oversimplified there by evaluating my bounds in terms of u because they wanted it in dx lah. And if this wasn't a definite integral, you have to resubstitute the x value, so I hope you keep that in mind. Now with that out of the way, I want to discuss how we can solve this question by not using integration. This is keeping in mind that you're probably a secondary 4 student who is watching my videos and may not know trigger substitution. I mean, you definitely won't know trigger substitution because you only learn it in like J1. So I'll walk through this with you. So whenever I do a bit higher order math question, I would consider this a higher order math question lah. I tell myself, why do I do the math? So by the second fundamental theorem of calculus, we know that one reason why we do definite integrals is to evaluate the area under a graph. So now, by using the formula of the integral of gx plus ux dx will be equal to the integral of gx dx plus the integral of ux dx. By using this formula, we can split up the bounds for these two graphs. So this will evaluate into 0 to 1 dx minus the integral of, but we're not doing integration. We have to solve this question without doing integration. So what's one way to help us visualize a graph? We plot it out. So by letting gx equals to this thing, we realize that this graph is actually a semicircle from -1 to 1. And you will realize that from 0 to 1 of this semicircle, it will be pi over 4 because of the formula pi r squared times 1/4 since it's a quadrant. So now let's evaluate this. So by graphical methods, you realize that this is a graph of, so this will be 0, 1, this will be 1, 0. You realize that this is 1 unit and this is 1 unit, so by your triangle formula of half times base times height, you will get. But the problem is they did not specify that it's an area question, so you just leave the units out. So you realize that this evaluates into this. Why did I want to make this video? So there are a couple of reasons why I wanted to address this. The first reason is because this is one of my favorite integral questions, and when I go JC, I want to challenge my classmates to this type of question. But the second reason is because of my might be biased opinion on mathematics. So the way my teacher has taught my class is that it's exactly what I said, that when you face a problem, you have to see what you're applying and then take it from there. But I think that a problem that the mathematics in Singapore faces is that our students are so inculcated into wanting the answer instead of like enjoying the mathematics or like applying it, because of how grades work and of how our education system works. But I like to highlight that mathematics isn't always about the answer. Sometimes it's the process of applying what you learn and we take together to do what is necessary. I'm kind of like offended as a person who enjoys math at the state of how mathematics is. One example of this is like my opinions of the A Math paper 2, and I know a lot of people are going to give me flack for this, but while I did find the paper difficult, right, I think that if you had the mindset of enjoying the paper, maybe not enjoying the paper, but applying what you have learned and not focusing on things like this and going, what is this? In case you didn't know, this means X is an element of R, which R means real numbers, which means, I mean, you probably know what real numbers are. Might be rational, but I think it's real. When I flipped through the paper while checking, I realized that a lot of people, because of how you view mathematics, were going to trip up when they looked at that. And while I will say that the paper is difficult, sometimes you have to calm your nerves and focus on the question itself. Sometimes you see something you don't recognize and you freak out, but then you have to tell yourself, hey, there's nothing that my teacher could not have prepared me for, and I need to focus properly so that I understand the thing. So TLDR, my honest opinion is that when you do mathematics, try to do a step-by-step process of why I do things. And as you can see, by applying what you have learned in mathematics, or at least in integration, namely this thing and splitting and this thing, and the second fundamental theory of calculus, where you integrate to find the area under a graph, you realize that your life wouldn't be as miserable as you think it is. And I think if more people did mathematics this way, instead of making it a competition and scream when you don't get an answer, I think that a lot more people will start to enjoy math as a subject and as a discipline as a whole. Anyways, I hope you enjoyed yourself watching me talk about my favorite integral question. That's all for today. I plan on doing my discriminants episode in quite a while, but I've been kind of lazy, and yeah, I promise to get it up and running, but yeah. Anyways, till next time when I find more questions that make me very entertained and remind me why I enjoy this subject. Thank you.